So here, Pauli came out on top, we say, and he's known for the Pauli exclusion principle, which tells us that no two electrons in the same atom can have the same 4 quantum numbers. So let's just think exactly what this means. And that means that if we take a wave function and we define it in terms of n, l, and m sub l, what we're defining here is the complete description of an orbital. In contrast, if we're taking the wave function and describing it in terms of n, l, m sub l, and now also the spin, what are we describing here? An electron. So now we have the complete description of an electron within an orbital. So that's an important distinction to make. What 3 quantum numbers tell us versus what the 4th quantum number can fill in for us in terms of information. So what that means is that we're limited in any atom to having 2 electrons per orbital, right? Because for any orbital, we can either have a spin-up electron, a spin-down electron, or both. So if we look at neon just as an example, neon has 10 electrons in it. And once we look at all the orbitals written out here, this is probably a familiar thing for you to look at, but it's important to think about why, in fact, we don't just put all 10 electrons. Why wouldn't they just want to go in that ground state, that lowest state, right? That should be the most stable, the lowest energy orbital for it to be in. And the reason they can't do that is because of the Pauli exclusion principle, the idea that all of the electrons have to have a different set of 4 quantum numbers, so only 2 of them can have the same set of 3 quantum numbers here, because for m sub s, we're only left with 2 options. So let's try a clicker question. And thinking about the Pauli exclusion principle, it might look a little bit similar to a question we just saw, but hopefully you'll find that it is, in fact, not the same question. So you can go ahead and take 10 seconds on that. Okay, great. So most of you recognize that there are 4 different possibilities of there's 4 different electrons that can have those 2 quantum numbers. Actually, the easiest way is probably to bring this down here. And the next highest percentage of you thought that we still only had 2. So remember, we solved this problem earlier in the class, but we were talking about orbitals. So there's 2 different orbitals that can have these 3 quantum numbers. But if we're talking about electrons, we can also talk about m sub s. So if we have 2 orbitals, how many electrons can we have total? Yeah, so we have 2 orbitals, or 4 electrons, that can have that set of quantum numbers. So you'll notice in your problem set, sometimes you're asked for a number of orbitals with a set of quantum numbers. Sometimes you're asked for a number of electrons for a set of quantum numbers. So make sure first that you read the question carefully and realize the difference that is between the 2. So that's where we'll end today. So on Friday, we'll start with talking about the wave functions for the multi-electron atoms.